Welcome to Unit 2, Lesson 15, the last lesson in Unit 2, the remainder theorem practice problems. Okay, looking at this polynomial, this is the remainder theorem. Which factors make 0? So we get here's a 0 when it's equal to 0. So we get 3 zeros. This one is not a 0. This is a y-intercept because 0 is the input and you get a number as your output. That's your y-intercept. So, all right, now we have listing the factors. We have x equals -2, x equals 3, and x equals 1. So what we want to do is change the signs. X plus 2, x minus 3, x minus 1. And that's what f of x is, factored. If I multiply this out, I will get this polynomial up here. So we answered the question. Rewrite as a product of linear factors. Okay, so this is just like the one problem from the lesson. Basically, what you're going to do is put all of these into y equals. So you're going to hit the y equals button on the calculator. And put this in the y1, that one in the y2, that one in the y3, that one in the y4, and this one into y5. Now, if you don't have the Calculate 84 on your phone, delete a couple of pictures and or a video and download that onto your phone, and now you can put these in. You put them in, you're looking for x is equal to 4. To change a factor into an intercept, you set the factor equal to 0 and then solve. And we know we add 4, x equals 4. Okay, so now, once you put all 5 of these in, when x is 4, scroll over and look for where all the y values are 0. And there should be 2 of them. If you put them in the calculator, you should see that A and D work. A and D both make 0. If you did not get 0 for A, for y1 and y4, go back to y equals, check your all your signs, check all your stuff, make sure you put it in correctly. Okay, so now for this one, look, they give you a choice. Write a polynomial function with degree 3 that has p of 7 is 0. So we know that x equals 7, y equals 0. So this is a factor, a root, or 0. So p of x is equal to, switch the sign to make it a factor, because it has to be set equal to 0 to be a factor. And then pick any 2 terms you want. I don't care, x plus 1, x minus 2. Anything you want. These 2 could be anything you want. But x times x times x. Or you could show multiplicity by doing x minus 7 cubed. Or you could do x and then x minus 7 squared, and then you would need another term. You can write anything you want here. But you need the x to be 3 times. The square outside means this x is squared times another x will give you x cubed. X times x times x gives you x cubed. X to the 3rd power is x cubed. So anything you want for that one. This was wide open, your choice. Okay, long division was used here to divide the polynomial function. Okay, by x minus 5, well, x minus 5, the actual root is x equals 5, and x equals -5. So p of -5. What is p of -5? That's x equals 5, the x plus. P of -5 is 40. And p of +5 is 90. The remainder matches the answer. Okay, so let's look at this one here. You're going to see this a lot on standardized tests. We know that the root is 5. We know that the root is 5. But when you switch the sign here, you get -5. So A and B don't work. So now, let's move to C. Change the sign, I get +5. Change the last sign, I get -7. They match. So now, I got to set 2x minus 3 equal to 0. I add 3 to both sides. I get 2x equal to 3. I divide by 2. I get x is equal to 3/2. This is 2/3, not 3/2. So C doesn't work. So the only possibility is D. Okay, now for this one. They give you this polynomial and they give you 2 factors, which means that x equals 0. So when we divide this out, we will get the answer of 0. So let's write x plus 3 into 3x to the 4th plus 8x cubed minus 13x squared minus 22x plus 24. 3x cubed goes right here. That gives me 3x to the 4th. 9x cubed. Change both signs to negative. That changes. You get -1x cubed minus 13x squared. So I'm going to do -1x squared. It's going to give me -1x cubed. It's going to be -3x squared. I'm going to change both signs, cross out the leading term. Different signs subtract, so watch this. This is positive, this is negative. So different signs subtract. 13 minus 3 is 10. Take the sign of the larger number. I get -10x squared. Drop the next term, -22x. This is going to be -10x because I matched the first term. Change both signs, cross that out. 30 minus 22 is 8x, bring down to 24. Multiply by +3. I get, 8, I'm sorry, by 8, because I got to match the first term. 8x times 3 is 24. Change both signs, I get 0. So x plus 3 is a factor. Now, because this is x to the 4th, I am going to have to divide again, but they give us another factor, x plus 2. So I'm going to do this division again on the next page. Okay, so now we took our quotient from the previous page. We take our next factor of x plus 2. We divide it into our quotient, the answer from a division problem. And now we got 3x squared, multiply to match the first term. We get 6x squared, change both signs, cancel out the first term, same signs add, negative and a negative, same signs add. So that's -7x squared minus 10x, match the first term, minus 7x, -7x squared minus 14x, change both signs, the first term cancels out, different signs subtract. 14 minus 10 is 4. Take the sign of the larger number, which is positive, plus 8. And then plus 4. Multiply to match the first term. Change both signs. You get 0. So this is how we know that they're both factors, because our answer is 0. So now we get 3x squared minus 7x plus 4. Then we're going to have to break this one down. I'll do that on the next slide. Okay, so now we have to factor this one. To factor with a leading coefficient, there is a way to do it, but I've always found the best way is to use a trial and error method. So you're going to have to try factors. The sign in front of the third term tells me both signs are the same. The sign in front of the second term tells me the sign of the larger number. So I know both of these are going to be minus. So now I need the factors of 4, which is 1 and 4 and 2 and 2. But because this has the leading coefficient, I can't add them and subtract them. I'm going to have to move them around. So if I try 1 here and 4 here, When I do the 3x times 4, I get negative 12x minus 1x. That doesn't work. That's larger than negative 7. So I had to try something else. Let's see. What happens when I move a 4 and a 1 around? And this becomes tedious when the numbers get large. So 3x times x is 3x squared. I know that works. 3x times negative 1 is negative 3x. Times that is negative 4x. Times that is positive 4. I get 3x squared minus 7x plus 4. So these are my factors. So x plus 3 is a factor. So q of x, let's do this in a different color. Q of x, if I write this as linear factors, is x plus 3, x plus 2 times 3x minus 4 and then x minus 1. So those are all 4 of my factors. I got 4 factors. I got a 4th degree, so it all works out. Okay, we know these things about a polynomial. It has degree 3. So cube, it means it ends in different places. Its leading coefficient is negative. Okay, so that's important. It has zeros at negative 5, negative 1, and positive 3. So we know x odd starts high, ends low. We know that, negative x odd. So 5, 1, and 3 make positive 15. The y-intercept is positive 15 if you just multiply the roots or the constants. So if I start high, I come up. I could always just graph it, but something like that maybe. Or maybe the height is before the y-axis. I don't know. But that's a guess. They're not asking us to get us precise. They say sketch a graph, and there you go.